When you're building something, say like this chair, you probably want to save yourself some time and money by coming up with an optimal fabrication plan. Here's an example of the kind of trade-off you might encounter with conventional fabrication plan optimization methods from prior work. Here, fabrication plan A uses fewer pieces of stock than plan B, reducing our material cost. Fabrication plan B has fewer cuts, reducing our manufacturing time. But what if you could modify your design in ways that preserves your original model but produces more optimal fabrication plans? You could imagine that there are potentially much more efficient fabrication plans achievable by just changing a few parts. The main challenge with this approach is that the search space is extremely large. Each design variation brings with it an entire landscape of fabrication plans with different trade-offs. Our work uses a novel data structure and new search algorithm to address this problem and co-optimize design and fabrication. After co-optimization, we generate a Pareto front of fabrication plans, some of which come from different designs that trades off different fabrication cost objectives. Here, we compute how much we saved in each dimension compared to the input design. We can also think about the total cost in terms of money and examine how much we save if we were to hire a carpenter to manufacture these plans at, for example, $40 an hour. We can select one of these plans to fabricate. Here are some additional results that showcase how design variations enable better trade-offs. A hobbyist enjoys the process of manufacturing but wants to save money. Here we find a plan for the bookcase that saves 25% in material. On the other hand, perhaps a volunteer offers to make a large number of windows for an organization with free access to recycled materials. Then they can use our approach to save 58% fabrication time for each window, a huge time savings. If creating a very precise item is imperative, then the carpenter needs to manufacture it exactly without saving time or material. Say that they are making a loom, which might require compatibility with other off-the-shelf parts such as reeds. We can find a solution that reduces error by 61%. Often, a user won't want to save in one dimension at the cost of all the others. For example, when hiring a carpenter at $40 an hour and paying for materials, the total amount of money leaving the pocketbook is what matters. For this objective, we find that even on our largest and most visually complex model, the jungle gym, we can reduce total cost by 11%. Thank you, and please refer to our paper for more details.